Hi guys, this is part 2 of the substitution method, and now we're going to take a look at two examples here. I'm going to do this first example with you. The second example then I'll have you try on your own, and then I'll go over it with you after you've completed the problem. Again, we have two equations here, and we're going to go over now the steps to solve this here. I'm going to work this out for you. We have a system of equations here, and we have to first identify, if we look back at our notes, which equation is solved for a variable. In this case, I see my top equation here is y equals x minus 3. And I'm just going to go ahead and put a rectangle right around y equals x minus 3. It is solved for the variable y there. If I look at my next equation there, I see that's in standard form. I have 2y plus 2x equals 18. Okay? I'm going to put a little box here, little rectangle around y. All right? This is going to give me a little bit of hint here about what I need to do. All right? If you remember, this method is called the substitution method. So here's how this is going to work. We know what y equals right now. It tells us right here that y equals x minus 3. So what we're going to do now with x minus 3 is we're going to substitute that in for y down below here, okay? And again, this means 2 times y. So we're going to say now this means 2 times x minus 3 plus 2x equals 18. We are substituting for y because we know what y is in the top equation there, okay? So this is what it looks like here. This is my first step here when I substitute. So you can see I replaced y with x minus 3 because that's what y is. Y equals x minus 3. All right, so now this method becomes pretty convenient because I don't have to solve for y to try to use the equal values method now. Okay, I can just substitute instead. Will be a lot more efficient, a lot quicker. Now, once you get down to this step right here, you've had this practice throughout the year. Now we need to get rid of the parentheses here. And if you look here, the letter that I'm going to solve for is x. I don't see any y's here. I just see the letter x. That's what letter I'm going to solve for now. Okay. So I'll go over this with you. I'll go through it pretty fast because we've done this before here. I'm going to make my rectangle for 2 times x minus 3. 2 times x is 2x. 2 times negative 3 is negative 6. Now I can kind of pull that out of the parentheses there. All right. Next, now I'm going to solve for x. I can see now that I can pull my 2x minus 6 out there, and now I have 2x minus 6 plus 2x equals 18. All right. And now I'm going to go ahead and combine like terms, which I have here 4x minus 6 equals 18. Again, all I did was add 2x and 2x to get 4x. And now I'm just going to solve for x, what you've been doing all year here. So I'm going to add 6 to both sides, and I get 4x equals 24. Divide by 4 on both sides. Again, you've done this, and get x equals 6. Okay? Again, a big mistake here. Would you tell someone around you what a big mistake might be now? Once people solve for x, what do they forget to solve for? Or if they're solving for some letter, what do they forget to solve for in this type of situation? Would you go ahead and tell someone who's sitting around you? All right, moving on. Hopefully you told someone in this case, well, we solve for x, and then people kind of forget they have to solve for y. Again, remember, we're doing this because we want to find the point of intersection of the two equations there, of those two lines. All right? So now all I'm going to do is I'm going to substitute in 6 back from my original 6 back into one of the equations here and solve for y because I've already solved for x. So I'm going to substitute now in 6 for this top equation right here. I'm going to substitute in 6 for x. And so now I just replaced 6 with x here, and now I'm going to solve for y. Okay, it doesn't matter which one I use here, but the top one to me looked a little nicer, a little easier here. All right, so now I see that 6 minus 3 is equal to 3. And so now my point of intersection here is the point 6, 3, okay? Again, the only different step today was this first step where I needed to substitute here, okay? All right, and finally, to check over my answer, 6, 3, I'm just going to plug in into one of my equations here. I'm going to plug in 6 for x and 3 for y. Well, I see right now that when I do this here, I see that I'm going to plug in 3 for y here, so I have 2 times 3 plus 2 times 6. And sorry if this looks a little crumbled, excuse me. And I'm going to then put a parentheses around that because that means 2 times 6, all right, equals 18. So now when I check over my answer here, I have 2 times 3, which is 6, 2 times 6, which is 12, and 6 plus 12 equals 18. And so now I know I've checked over my answer here, and I know that solution, or that point of intersection, makes the systems of equations true there, okay? All right, moving on to the next example. Again, if at any point you need to pause and go back, please do so. Here's the next example that I want you to try on your own here. Would you go ahead and do that right now? So this system here reads x equals negative 3y plus 1, and then 4x minus 3y equals negative 11. Try that on your own. All right, moving on here. If we look here, this situation here is a little bit different. Notice that this time we're going to identify which variables is solved for here, and we see that it's being solved for x and not y this time, okay? So just be aware that it doesn't matter. It's not always going to be solved for y. It's not always going to be solved for x. You have to identify that. But this is a good case here for substitution. So if I look here, I'm going to, again, place a little box right around, or a rectangle right around x equals negative 3y plus 1. And then I'm going to put a box around my x here, or a rectangle. I know now that I can replace x with negative 3y plus 1 because that's what x is. All right? So take a look at my substitution step right now. Again, this means 4 times x, so I'm going to take 4 times, and that's why I put it around parentheses, negative 3y plus 1, because that's what x is. Minus 3y equals negative 11. Now ask yourself the question, what variable or what letter am I solving for right now? Go ahead and tell someone what letter you're going to solve for. All right, moving on here. The letter that I'm going to solve for is y, but I first have to get rid of this parentheses. So again, I'm going to make my rectangle here to get rid of my parentheses. And so now 4 times negative 3y plus 1 turns into negative 12y plus 4, okay? And so now I can solve for y here, all right? And when I solve for y, I see that I can write it like so. Negative 12y plus 4, I'm rewriting this without parentheses now, minus 3y equals negative 11. I'm going to go ahead and combine like terms here. And so now I see that we have negative 15y plus 4 equals negative 11. I'm going to subtract 4 on both sides, and now I'm just in the process of solving for y. And now I have negative 15y equals negative 15. Again, I want to get y all alone on one side. So I'm going to divide by negative 15 on both sides to get y alone. And I see now that y equals 1. Y equals 1. All right? So now that I know what y is, I need to solve for x. Remember, I want to find the point of intersection there. All right? And so now I can pick either one of the equations up top here, and I'm going to substitute 1 in to one of the y's, either in this top equation or the bottom one. Again, it does not matter. What I chose to do was I chose to substitute 1 in for the top equation here for y. Okay? So take a look right now. I'm substituting in for this top equation right here. I replaced 1 with y here, and now I'm taking negative 3 times 1, which is negative 3, plus 1, which is negative 2. And notice now that I'm solving for x here, okay? So x equals negative 2. I just replaced y with 1 to solve for x there. So now my point of intersection here is the point negative 2, 1. And again, to check my answer, I can put this point of intersection in for both x and y.
Isabella Pritchard, your ride is waiting by the 6th grade door. Isabella Pritchard, your ride is waiting by the 6th grade door.
Sorry about that. Now I'm going to go ahead and check over my answer here. So now I'm going to replace, I'm going to substitute x and y in for one of the equations here. I'm going to pick the one in standard form. Again, I don't have to. I'm going to replace negative 2 with x and 1 with y. So now I have 4 times negative 2 minus 3 times 1. Again, just replaced x with negative 2 and y with 1. I'm going to go ahead and solve that now. 4 times negative 2 is negative 8. Minus 3 times negative 1. Well, I know here that negative 3 times 1 is negative 3. And so I have negative 8 minus 3 equals negative 11. And I know that negative 8 minus 3, make that a little darker there for you, is negative 11. And so negative 11 equals negative 11. I know that I've done it correctly here. Okay? Guys, this was a lot here. Please go back, stop and rewind, pause if you need to, and please ask questions if you have any when you get into class. Thank you very much.